Hey guys, how you doing? Yesterday you took a look at a new strategy to help you with two-digit multiplication, and that is the rectangular area model. You guys are familiar with area, and as you guys remember, we talked about length times width equals area. Well, this rectangle, if you multiply the length times the width, that will give you the area. So what we're doing is we're setting up this problem to help you to visually see the representation of multiplication, two-digit multiplication. And why am I saying two-digit multiplication? Well, because 10 and 5 is 15. 1, 10, 5 ones. That is a two-digit number. 15 is a two-digit number. 7 obviously is a one-digit number. So what is 7 times 15? Well, what you want to do is you want to multiply that by 7 times 10 and then 7 times 5. And basically, think about place value. There is 110 and 5 ones in the number 15. So you're multiplying 7 times the tens and 7 times the ones. And as you guys can see, 7 times 10 equals 70. There are 70 small little units here. And 7 times 5 is 35. If you add these two numbers together, 70 plus 35, it equals 105. So this is what we refer to as the rectangular area model. We're going to move forward to the next slide. So now you're taking a look at a more complex problem. 32 times 14. When you get to middle school, the multiplication symbol that looks like an X will turn into a small little dot. And the reason why they do that is because often they use variables like X, Y, or Z that represent a number, and that could confuse you with multiplication. So basically what this says is 32 times 14. And I know this is very complex. This is what you'll be doing in 4th grade, and I wanted to kind of, support you, and frankly, the kids that have mastered the multiplication facts are ready for this. So 32, what we want to do is we want to think to ourselves, okay, this is a two-digit number. So as you can see, there are 3 tens, which is 30, and 2. That's 32. 10 plus 4 is this two-digit number, 14. So really what we can do is we can go, okay, 10 times 10 is 100, 10 times 10 is 100, 10 times 10 is 100, and then 10 times 2 is 20. Okay, and then we come down here, 4 times 10 is 40, and then once again, you would just repeat that. And then ultimately 4 times 2 is 8. You can see there are 8 small little units. Now, this is really breaking it up, but in further slides, I'll show you a different strategy. Okay, and so once again, I kind of verbalized that, and you can see that you would add up all these partial add-ins. What is 32 times 14? Well, you would add up the 3 100s, the 3 40s, the 20 and the 8, and that is a great way to help you to figure out 32 times 14. Now, here's a different way. Rather than breaking up the 40 into 4 tens, I'm just going to write the number 40. And then rather than breaking up the 20, the 2 tens into 10 and 10, I'm just going to write a 20. Now here's a little trick. All you really need to know is 4 times 2, which is 8, and then you're going to add 2 zeros. So 4 times 2 is 8, but what is 40 times 20? Well, if you know that 4 times 2 is 8, what you have to do is place the additional 2 zeros next to 8, and 40 times 20 is 800. And I know that's new to you. Don't worry about it. We'll walk you through that. What is 4 times 3 over here? Well, 4 times 3 is 12. And so if you know that 4 times 3 is 12, then you know that 40 times 3 is 120. And then we'll practice this. 6 times 2 is 12. And then if you know that 6 times 2 is 12, then you'll know that 6 times 20 is 120. You just add 1 0. And then 6 times 3, boom, you guys got that. All right, so this is what we're doing. We're basically creating a rectangular representation of two-digit numbers, and because we have 2 digits times 2 digits, you have tens and ones, and then you multiply them across. Okay, we'll continue. So we just figured out that 40 times 20 is 800, 40 times 3 is 120, 6 times 20 is 120, and 6 times 3 is 18. These are called partial add-ins. What you're going to then do is add up these 4 partial add-ins to figure out what 46 times 23 equals. Okay, there we go. Now, your mother, your father, even individuals older than us learn something that's called a standard algorithm. And it's much different than what we're trying to show you right now. And a lot of kids will learn that process, but really may not truly understand what they're doing. And I will demonstrate the standard algorithm a little later. In fourth grade, you will be taught that as well. But what's really great about using these two strategies is if you get the same answer, then you know that your process, your solution is correct. If you get differing answers, then frankly, we've made a mistake. So using different strategies for the same problem, solving it two different ways, is a great way to check your work. Okay? Look at this. How many small little squares are here? It's pretty gnarly. I mean, if you were to count them one by one, that would take an incredibly long time. But there's a little trick. 3 tens, okay? And 4 ones, 5 tens, and 6 ones. And basically what I'm doing is I'm thinking to myself, okay, look at that's 3 tens. This is 4 ones. This is 5 tens. This is 6 ones. I'm going to break this rectangle into 4 parts. Watch. Okay? So we're going to break it into 2 parts. And here are the parts. There's the 50, and there's the 6. Okay? 56. There's the 30, the 3 tens, and then the 4 ones. And basically, all we really need to know is 3 times 5, 3 times 6, 4 times 5, and 4 times 6. There's basically 4 multiplication facts that we need to know, and then all we have to do is carry the zeros. So 3 times 5 is 15. Take a look, and then you place 2 zeros because we're not really solving 3 times 5. We're solving 30 times 50. And look at 3 times 6 is 18, and then you would carry that 1 0. And if you know that 3 times 6 is 18, 30 times 6 is 180. Take a look down here. 4 times 5 is 20, but we're not multiplying 4 times 5, we're multiplying 4 times 50, and that's 200. Okay, and last but not least, I know that's a little hard to see, 4 times 6, boom, you guys got that. So what we're going to do is we're going to then add these partial add-ins, the 4 numbers that I just showed you. One of the things that I probably do not like about this setup is that my 1s are not on top of one another, my 10s are not on top of one another, my 100s are not on top of another, and if you do not set them up vertically, meaning up and down in a nice, neat line, you'll make a mistake. I'll be honest with you guys, when I did this the first time, I actually got a wrong answer, and the reason why is because I did not set them up properly. It was really hard to place all 4 numbers in nice, orderly fashion, and I made a mistake. And so learn from my mistakes. Set everything up. Make sure the 1s are all on top of each other. The 10s, they go straight down the line, up and down, vertical, okay? There's a 4-digit number here, the 1s, 10s, 100s, and 1000s, okay? And guys, I think we're done with our lesson. What I'd like to do is I'd like to go ahead and just kind of talk about Khan Academy. And as you guys are going to see, I'll be sharing this with you Friday morning. Don't stress out. This is something that I want to challenge those kids that are ready with their multiplication facts and are ready for 4th grade. And what better time than to start practicing this. So once again, I'm going to use Khan Academy to challenge most of my students in this class. All right, so take a look at this area model. Basically, we have 58 times 34. Okay, so what do we need to do? Well, we need to think to ourselves, what is 3 times 5? Almost everyone knows that. We're going to make that a 15. And then remember, if you know that 3 times 5 is 15, then you know that 30 times 50 is 1500. Why? Well, take a look. There's 1 0 there. There's 1 0 there. Those 2 zeros are going to be placed in that portion. Next, 3 times 8 is 24. Sorry, my scratch pad is a little touchy. That is a 24. 3 times 8 is 24. I'll try to fix that too. And we're not figuring out 30 times 8. We're figuring out 30 times 8. So we're going to place an additional 0 here. And 30 times 8 is 240. 4 times 5 is 20. If you know that 4 times 5 is 20, we're going to just place that additional 0 there. And 4 times 50 is 200. 4 times 8. Everyone should know that really quickly. Boom. All right. So what we have here is 4 partial addends, 1500. B is 240. My 200 looks really funky. I apologize. 232. Now, remember, these are partial addends. So if you were to use a calculator and you figured out 34 times 58, you would add these up, and that would be the total. That would be the product. 34 times 58 would equal these 4 partial addends combined. Okay? Did I get it correct? Let's see, Dufour. You better got it correct. Oh, wow. What is the total area? Well, I guess, you know what? Let's add it up for everyone to see. Let's try to make sure that everything is nicely lined up this time. Unlike my PowerPoint presentation, there's the 200, there's the 4 tens, there's the 0 ones, there's the 200, 0 tens, 0 ones. Now remember, I'm trying to make sure everything is nice, neat, and orderly. You do not set up the problem correctly, nice, neat, and orderly. You're almost sabotaging your work. So let's look at this. All the ones, 0, 0, 0, and 2 is 2. There we go. We're going to add up the tens. 4 tens and 3 tens is 7 tens, which is 70. We're going to add up the hundreds. 500, 200, and 200 is 900. So that's 9 100s. And there is only 1,000. 1,972. So you guys have seen me talk about why multiplication facts are so important. And you can obviously see, really, all we need to know is 4 multiplication facts to figure this out. 3 times 5, 3 times 8, 4 times 5, and 4 times 8. And guys, unfortunately, when kids get to 4th grade that don't know their multiplication facts, this is where they struggle. There's so much going on. You have to know your multiplication facts. I've preached this nonstop. This is a perfect example of why in 4th grade, if we don't know our multiplication facts, things get tough. All right, I'm going to leave you with this. Boom. All right, kiddos. Pleasure seeing you guys these last couple days. Challenge yourself. This is a 4th grade concept, but frankly, we've got some amazing kiddos in this class that all can do this. They've been dialed with their multiplication facts and division facts for literally half the year. Challenge yourselves. Have a wonderful morning. Work hard, and we'll talk.